My lab 3, Black Hole by me, James Park. Okay. Table of contents, introduction, equation, part 1, part 2, and the analysis and summary. So for the introduction, there are two parts to the lab. Part 1, calculating the mass of the black hole, which in this case was 1.65 e to the 34. And part 2, determining the initial velocity to escape the black hole, which was here 1.67 e7 negative and 9.14 e6. And these two parts were used to demonstrate the knowledge of gravitation and its forces on an object. Alright, the equation of key concepts, we have Newton's second law, and we have gravitational force and velocity update formula, which we can see here. Alright, so for lab 1, which is lab 1 part 1, which is the black hole's mass, the initial conditions were there are black holes and a star. The mass of the star is 2 times 2e30 kg. The initial, where the time starts, is 0, and delta is 1 day, which is equal to 86,400 seconds, and the gravitational constant is 6.7 e to the negative 11. So looking at the code, first part we just use the momentum formula, P equals mv. Second part is just a change of momentum, which is equal to P final minus P initial, same thing for the velocity, but instead of using P, we use V. For dp over dp dt, which is just equal to the fnet, we know that fnet is equal to change in p divided by change in t, which is what we have here. And then that's also equal to fnet. And then now to solve for the parallel, we have to figure out what p hat is, which is the p divided by magnitude of p. And then this part right here, change of magnitude of p divided by change of p is what this is equal to. And then we multiply that by the p hat to solve for the fnet of parallel, which is right here. We do the same for the perpendicular one. Since we know that the net parallel plus net perpendicular is equal to fnet, we just use a simple algebra to solve for specifically the net perpendicular, and which we can tell is here. Now for the final part, since we know that fnet is equal to this just the gravity equation, we can just use algebra to solve for this equation to solve for the mass of the black hole. And my seed was my email. After doing that, you can see the results where fnet is equal to 9.45 e to 28, and parallel was 4.44 e to 27, and the perpendicular force was 9.44 e to 28. And in conclusion, the mass of the black hole was 1.65 e to 34. Alright, lab 2, solving for the initial velocity. So, initial conditions, there are three different parts: the planet, black hole, and the spaceship that's trying to escape from the graphs of the black hole. And you can see the black hole's mass is the same as the one we calculated before, and all the constants goes like this, where 6.7 e negative 11, 9 e28, 7 e10, and then this just to solve for the planet speed, the initial conditions, and the initial conditions for the velocity of the spaceship to escape is going to be negative 1.67 e to 7 and 9.14 e to 6. Alright, so the coding part. So all the coding parts use a specific equation, which is just going to be the gravity equation. It all uses it to solve it. So this part, this part, this part, and this part use the same equation, where this one calculates from how much black holes affect the planet, how ships affect the planet, and then we combine that to figure out the whole force on the planet. While this one is the same thing, but for the ship, so how much black holes affect the ship, how much planets affect the ship, and the whole net force on the ship. You just add it together. And the bottom here, we just use the position plus velocity update formula to figure out that the velocity and the position and the velocity position of a planet and the ship. All right, the results. The results look like this, where the purple or pink is a ship that just flies away, and this is the planet. So it escapes the grasp. Now, possible errors, approximation because of the code of simulation, and accuracy because the velocity that we found was an estimation by trial of error. Okay, discussion and conclusion. So what does this mean? How's a net force parallel perpendicular component different from the rate of change rate of momentum and its components? So mathematically and theoretically they are the same thing, but the only different thing is that one can be used by just looking at the change of like a momentum or the speed, But other thing, you have to calculate the whole net force, meaning all the forces, meaning it could be easier to solve rather than just the Fnet. And for what if, what's the initial velocity have to be for the spaceship to orbit around this hole? You can see that just calculating by trial and error, I got -1 e to the 6 and 1.11 e to the 7, and you can see the chart how it just makes a perfect circle. And that's my lab. Thank you.